So discuss about the first order linear differential equations. So first we define what you mean by a first order linear differential equation. And then we describe the method of finding the solution of such equations. So definition, a differential equation of the form dy dx plus p of xy equals to q of x is called a first order linear differential equation. Where P and Q P and Q are functions of x only, or they may be constants. So they are functions which depend on the variable x alone, but not the dependent variable y. So let's call this general equation, standard form of this first order linear differential. Let's call this one star. So the biggest question is to describe the method on how to solve star. So the question, how do we solve star? Now note that star is non-homogeneous equation. But if we put q of x to be 0, it becomes homogeneous and at the same time separable. Thus we write dy dx plus p of x y equals to 0, because we have let the right hand side to be 0. i.e., we'll have dy dx equals to negative p of x y, p of x y, and then multiplying through by dx We get this. And then dividing through by y, we get negative p of x dx. Now these are separable differential equation. Integrating, we get integral of dy over y equals to the integral of minus p of x dx. So which implies that ln of y is given by negative integral of p of x dx, say, plus a constant c. Now, if you raise both sides to e, this means that y will be e raised to a negative integral of p of x dx plus c, which is e raised to a negative integral of p of x dx times e raised to power c from loss of indices, which implies that y is a e raised to power the integral of negative p of x dx, where e raised to power c is what I'm calling a. So the quantity e raised power e raised power integral. Now, if you ignore the negative sign, p of x dx is called an integrating factor. Usually denoted by mu of x. So going back to star, multiply star by mu of x. So this is what I mean. So we had dy dx plus p of x y. So this side you multiply by e raised power integral of p of x dx equals to right hand side was q of x multiplied by e raised power integral of p of x dx. This will give e raised power the integral of p of x dx times dy dx plus p of x y e raised power integral of p of x dx equals to q of x e raised power integral of p of x dx. Now this left hand side is actually the solution for differentiating y times e raised power the integral of p of x dx equals to q of x e raised power the integral p of x dx. Confirm that this really the derivative of the product function y and the integrating factor. So that we'll get on integration. So now integrate the left-hand side, we get y e raised power the integral of p of x dx equal to the integral of q of x e raised power the integral of p of x dx, and then plus constant of integration. So this is the required solution for the given differential equation. Y equals to e raised power negative p of x dx, q of x e raised power the integral of p of x dx plus c e raised power negative integral of p of x dx. I've simply divided through by integral of this e raised power the integral of p of x dx. So this is the general solution of star. So generally now, generally, the solution of star is y times the integrating factor equals integral of q times the integrating factor plus with respect to x, and then plus c. Now, the solution of the star equation is not very complicated as the derivation of the steps are. What you only need is to define, to write the equation in the star form. Once you have that form, you identify P, and then from P, you write the integrating factor, and then proceed. So quickly, solve the equation x dy dx plus 2y equals to 12x. So what you do first is to write the given equation in the standard form, dy dx plus py equals to q. By doing this, you will now be able to determine the integrating factor mu. So once we have this, and then the integrating factor mu is usually given by the e raised power the integral of p dx. Now, we have x dy dx plus 2y equals to 12x. So the standard form requires the coefficient of dy dx to be 1. So we divide through by x, divide by x, divide by x. So which implies dy dx will be 2 over x, y equals to 12. So therefore, our P is 2 over x, our Q is 12. Now, next we get integrating factor. The so-called mu of x, which is e raised power the integral of p dx, which will be e raised power the integral 2 over x dx. So mu of x will be given by e raised power, integrating this one will be 2 ln of x. Now, when you are getting the integrating factor, though it is an indefinite integral for power of e, but we don't care about the constant of integration. What matters is the function itself. So this can be written as e raised power ln of x squared, which is just x squared. Let's call this standard equation, let's call it 1. So next, multiply equation 1, which is already in standard form, by mu of x, which is x squared. That is, we'll have, I remember this is plus sign, dy dx plus 2 over xy times x squared equals to 12 times x squared. Note that this is the derivative of the integrating factor x squared times the function y. That's usually the case, the y times the integrating factor. And when you expand this one, you get at the end of the day that you'll have this expression. So this will be 12 x squared. Now next, let's call this one equation 2. Integrate 2 with respect to x. So which means we'll have d dx of x squared y dx equals to integral of 12 x squared dx. Now, integration and differentiation are inverses, so this will gives x squared y equals to, this will give us 12 divided 3 is 4, x power 3, then plus c. And from this one, it's not hard to solve for y, so y equals to 4x plus c over x squared. So this is the final solution.